Hello everyone, welcome back to Coding Charms. After a delay, we are back with another video. In today's video, we are going to be solving the problem data stream as disjoint intervals. This is tagged as a hard problem. Let us read the problem statement. In the problem, we are given with a data stream input of non-negative integers, a1, a2, and so on, an. Summarize the numbers seen so far as a list of disjoint intervals. So we are given with some stream of numbers and we have to summarize those numbers as a list of disjoint intervals. So we have to implement the summary ranges class. Summary ranges constructor initializes the object with an empty string, and we have add number function which adds a number, adds an integer value number to the string. We also have the get intervals function which returns a integer 2D integer array, returns a summary of the integers in the string currently as a list of disjoint intervals start I comma end I. Okay, the answer should be sorted by start I. So the intervals should be in ascending order of the starting number. Okay, let's take a look at the example. So initialization, and we add the number 1. So next we have get intervals. Since we have only one interval, we return it 1 comma 1. Then we have to add another number. The number is 3. So we have 1 comma 1 and 3 comma 3. And we have to add another number. The number is 7. And we have 1 comma 1, 3 comma 3, 7 comma 7, all are disjoint numbers. And here we have 2. So here in case of 2, we have 1 comma 3 because 1, 2, 3 are, we can combine 1, 2, 3. So 1 comma 3 will become one interval, and then 7 comma 7. So we have two disjoint intervals. And again we have to add the number 6. After adding the number 6, we have get intervals 1 comma 3 and 6 comma 7. 6 and 7 will be merged into a interval. So we have two disjoint intervals 1 comma 3 and 6 comma 7. I hope you have understood the problem, and the constraint of the value goes up to 10 power 4, and each method will be called at most 3 into 10 power 4 times. Okay, so when I first say this problem, it looked like a union find because the names sound like that. The add number method is very much sounds similar to the union method, and the get intervals is like the get components. So we union all the numbers and we find number of components. But instead of doing it using graphs, there is a better approach we can use. So what if we add numbers to a sorted list? We can add all the numbers to a sorted list. How? When each time we get a number, we add it to a list in a sorted fashion. So let's take an example. So we have here 1. Let me write this thing. We have 1. So firstly, empty list, we add 1, and then we have 3. So we find the position where we find the position in the sorted list. After adding the number, it should be still sorted. So we should find the correct position where we should insert the number in the sorted list. So 3 will be added over here, then 7 will be added over here, and when we get 2, we find the position of the 2. So 2 will be added in the first position. So 1 comma 2 comma 3 comma 7. Again, when we get 6, we find the 6th position. The correct position is over here, so we add it. To find the correct position, we have two ways, right? We have linear search and we have binary search. Since we already have a sorted array and we have to find the position, we can use binary search. So using binary search, we can find the correct position in O of log n. So here we use binary search to insert the number in the correct position. So we can add the numbers to a sorted list using binary search. And when we have get intervals, so we have this list. In get intervals function, we can accumulate or we can form ranges from this. By iterating over this list, we can form the ranges. How? Firstly, we have this. We iterate 1 and 2. These are consecutive. 1 plus 1 is 2. 2 plus 1 is 3. So like this, we can find the ranges. And when we get here, 3 plus 1 is not 6. So far, we have seen one range. So we add it. We keep the minimum and maximum. So 1, 3. And we can have the start and end value. We do similarly here as well. So we get 6, 7. 7 is the end of the list. So we add 6, 7 to the list. This is one way of solving the problem. So what will be the time complexity? For adding the numbers, it will be O of n. We can it will be O of n to find the position, and to actually insert it, it will again be O of n. Inbuilt functions for insert takes O of n, right? So it will be O of n as well. And we take the maximum. So O of n plus log n will be O of n finally. And here again, we have to iterate over the list and form the intervals. So it will also be O of n. So both will take O of n. So here each will be called 3 into 10 power 4. So this approach will pass all the test cases for given constraints. But can we optimize it? See, if we can some way keep track of the intervals instead of numbers, we can remove this step over here, forming the intervals. If we keep track, what I'm saying is, instead of numbers, if we keep track of the intervals as a sorted list, then we can directly return the intervals, right? Return intervals. So then this will be reduced to O of n. O of n to O of 1. Okay, so how we can do that? Now, firstly, let's take a normal empty list. And firstly, we have to add a number 1. So we have no intervals. So we add 1, 1. And again, we have to add number 3. So we find the correct position where should we add 3 using the binary search. So we find this is 1, 1. So we should add here. So we add here 3, 3. And now again, we have number 7. So we find a position where we have to add 7, similar to what we have done before. So we add 7, 7. And now we have 2. For 2, we find the correct position. So we have to insert it. We first insert it over here. And 2, 2. But here we are keeping track of intervals, disjoint intervals. So what we do now, 1, 2, 3 form a single interval. How will we do that? So currently inserted interval is 2, 2. So let's say this as I. And what we do is we check if the current start is equal to previous end plus 1. Okay, if this is the case, then 2 and 1, we can merge these two intervals because these are consecutive numbers. We can merge these two intervals. Now what we do is we make this as 2 and we delete this or erase this interval. So now we have merged the front and the current positions. Again, now what we have to do? Now this will be I minus 1. So now we'll increment the I value. So now this will be I and this will be I plus 1. And okay, now we have I 1, 2 and 3, 3. We have to again see if the next, now what we do is current n is equal to next start minus 1. if this is the case, if current end equal to next start minus 1, so 2 is equal to 3 minus 1, right? In this case, we merge these two intervals. How do we do that? So what we do, we make this starting position as previous start. So we replace this with 1 and we pop this value. So now the new intervals, new disjoint intervals will be 1, 3 and 7, 7. Now we again have to add the number 6. Where we can add the number 6? Here, in this position. In the first position, we have to add 6, 6. So this will be our I, and we check if current start equal to previous end. So 6 equal to 3 plus 1. No, this is not the case. Both are not continuous. So we check the next condition. If the current end is equal to next start minus 1. So 6 equal to 7 minus 1, right? So these are continuous values. So we merge these two. How do we do that? We make the next starting value as current starting value. So we make it 6 and we remove this value. So this will be our final intervals and we return them. So this is how we solve the problem. Let's code it up. Let me remove this and let's write the steps. So what we have to do, first we have to find the position by performing binary search, and then we have to merge a front interval and merge next interval. Before that, we have to insert the interval. So first let's perform binary search. In binary search, we have left value. Left value is 0. And we also have the right value. Right value will be let us define intervals. So let me code it up in C++. So, okay, let me copy this and move to C++. Okay, so let us have a vector of pair of int comma int intervals, and we have to do intervals dot size minus 1 to get the right value. Now we will do a while left less than or equal to r, right? Next we find the mid position, left plus right divided by 2. And now what we have to check? We have to check if mid intervals of mid, the starting value of the current interval is less than or equal to value, and value is less than or equal to intervals dot end value. If this is the case, means if we have 1 to 1 comma 3 as our current interval and we got 2, so there is no need of inserting 2 anywhere, right? We have already covered it. It is already covered, so we just ignore it and we return. Else, if intervals of m0, so the starting value is greater than the given value, then our value, we have the position lies before. So what we do, we make right equal to mid minus 1. In the other condition, we make left equal to mid plus 1. So finally, what will be our position? Our position will be left. Now what we have to do, we have to insert intervals dot insert intervals dot begin, it takes iterator, begin plus I. What we have to insert? Value comma value, and now we have to merge. To merge the front value, first we have to check if the front value exists or not. The front value exists when I is not equal to 0. And if we know that the front value exists, what we have to check? We have to check if previous and value plus 1 is equal to if previous and value is plus 1 is equal to current value, then these are consecutive numbers. In this case, what we do is we make previous and value as current and value. And what we do now, we pop or we erase the current interval. So for that, interval start begin slash I. Now we erase. Now that we erase, our I value decreases by one step, and now we have to merge the next interval. To merge the next interval, we have to firstly check if the next interval exists or not. For that, if I value is not equal to interval start 5 minus 1, then we know the next value exists. If the next value exists, we have to check if the next starting value minus 1 is equal to the current value. If this is the case, we have to make the next starting value as current intervals starting value, and we have to erase the current interval. So erase the current interval start begin let's I, and now we have merged the front and with the back. The add number operation is done, and now we have to get intervals. In get intervals, we have to just return the intervals. Looks good. First, we have found the position to insert the interval, and then we have inserted the interval in that position. Then we check if we have to merge with the front interval or not. If it is necessary, we have merged, and then we have merged with the next interval as well. And in get intervals, we have returned the intervals. Let us run the code. Okay, we have an error. If intervals does not have a subscript. Interval. Let's make this as vector of vectors instead of space. Value. It passes the sample test cases. Let us submit it. It passed all the test cases. So as we have discussed, the time complexity of add number is O of n. Because to insert, the time complexity of insert is O of n. So the add number time complexity is O of n. Here we are directly returning the interval. So the time complexity of get intervals is O of 1. I hope you have understood today's problem. If you did, make sure you hit that like button and subscribe Coding Charms for more daily videos. See you in tomorrow's video. Till then, take care. Bye-bye.